Welcome to the Biochar Show, where innovation meets sustainability. I'm your host, Megan K. and today we're diving into how creativity is transforming one of the world's largest environmental challenges into a powerful solution for soil health, carbon isolation, and beyond. Joining me today is Raymond Apy, the CEO of Northeastern Biochar Solutions, based in Saratoga Springs, New York. Raymond leads a company that's revolutionizing biosolid disposal by turning a waste problem into a sustainable soil restoration solution. Through their proprietary thermal treatment technology, they're producing enhanced biochar that not only helps manage odors, air emissions, and greenhouse gases, but also creates a clean, carbon-rich product with far-reaching benefits for agriculture, manufacturing, and waste management. With over 30 years of experience spanning engineering, sales, leadership, and business strategy, and a master's degree in environmental science and policy, Raymond brings a wealth of knowledge to this conversation. His work is deeply rooted in health, safety, and environmental conservation, and his mission is clear: to make the world a cleaner, greener, and safer place to live. I'm excited to learn more about Raymond's journey, his company's groundbreaking technology, and his vision for biochar's role in addressing environmental challenges. Hello, welcome.
Thank you.
How's your day going?
Going well so far. Can't complain.
Yeah, you're on the East Coast.
It's a little gray out today, but not too cold. We are expecting some more weather coming in soon, but right now we're kind of in between storms.
Oh, yeah, here it's sunny, so can't complain. You got to take it while you can. So, welcome to the show, and I thought we'd dive in and learn a little bit about you and your company. First of all, you have 30 years of experience in engineering and sales, leadership, and business development. What inspired you to move into biochar and sustainable solutions?
Well, that's a good question. It's one of those ones where I could make the answer really short or go on and on. So I'll go somewhere in between. So first of all, I went to undergrad and graduate school to study environmental sciences and engineering and policy. And I worked, during graduate school and after graduate school, I worked in toxicology laboratory. I worked for an environmental consulting firm and things of that nature. And then I took a job with the U.S. District Court in New York. And I because I had enough graduate credits to qualify as a paralegal. It was really more of a financial move because it was a pretty good job with federal benefits. And I did that for a little while, and I really thought I was going to go into environmental law. I kind of wanted to do that. I took the LSAT, and I had applied at Syracuse University. But then the change event was I got this opportunity to have a real shot at a systems engineering job for a technology company that was based in New York. And I had a background, and at that time, so now we're talking mid-90s or 1996, I guess. At that time, there weren't a lot of people out there that had a really solid understanding of client server and networking and those things. And for some reason, I just always gravitated. It just came naturally to me. I liked it. I like technology. I like computers. I understood networking. I understood data storage and those kind of things. And in the context of the 90s, not in the context of now where it's all cloud and way beyond me at this point. But anyway, I took this job and I advanced through that company from engineering into sales management, and leadership. I ended up becoming the CEO in 2008 and ran the business for about 9 years. In the first 6 years, we doubled revenue and quadrupled net income. So it was a pretty good run. And it went so well that the owners decided they wanted to sell it because it was quite valuable at the time. And it was, you kind of like get out while things are good sort of thing. So we sold the business, and that was good. But I was way too young to retire. I actually took an 18-month deal with the buyer, which was a national technology firm that bought. We were a regional firm. National firm called Converge One bought us, and I did an 18-month deal with them. I stayed a little bit longer, but eventually I kind of got a little bit tired of that, wanted to try something else. So I pulled my parachute, and I started looking into like everybody that I knew who was in their early 50s and, could retire but kind of want to stay in it. They all go into real estate. Everyone's buying a property and they're going to do rentals and things like that. Well, anyway, I looked into that for a little while, and it didn't spark any passion at all. And I just couldn't see myself being like a property manager on a small scale. And I wanted to find something impactful. Well, meanwhile, in working with assessing different properties and the potential value and income potential for those, through my accountant, I learned about this thing called biochar, which I had heard about abstractly in the past. It's not something that was a thing when I was, in my environmental science and engineering days in the 90s. So I took a look at it, and I got connected with a company that was manufacturing equipment for rotary thermal drying rotary equipment that was used for drying all kinds of things that need to be dried. And so, for example, one of their bigger clients was like Tyson Foods, and they would dry leftover chicken parts and gross stuff like that and grind it into dust, and so the company could use it for other things. But this company had recognized that this technology could be applied for drying and then in an advanced state, pyrolyzing biosolids, which is a regulated waste. A lot of people don't know what that is. It's basically the sludge that comes from wastewater treatment plants. It's not raw sewage. It's been treated at a very superficial level. Biosolids are basically a wastewater treatment plant skims the water off, treats the water, releases the water back out into the environment. And the best path for that is, into a large water body or into a fast moving water like a big stream or river. And that's pretty common. And sometimes there's chlorination, or there's the use of ozone treatment, or just aeration to reduce the pathogen count and make it safe. And so that's how the water's handled. But what's left of the solids that settle out in the bottom, and typically there's a couple different ways to manage that, but typically the wastewater treatment operators they'll run that through settling ponds, and they'll add bacteria to it, and the bacteria will actually consume all of the organic matter in there, and the population of bacteria explodes because there's that food source for it, and then it runs out of food and it dies. So some people in the industry refer to sewage sludge or biosolids as a bunch of dead bugs, which in a sense it kind of is in that regard. But it also has, it catches a lot of the kind of the nasty stuff that ends up in wastewater from industry. Most industries in most states are required to pre-treat, any kind of toxic effluent. There's pre-treatment, and that's regulated by the EPA and the state level. But there's a lot that does go through, minor sources of hydrocarbons. Like think about like the wastewater that leaves a car wash. You just washed a car and you blasted water up on the other side. Inevitably, there's going to be little oil residue or grease, things like that. So, light manufacturing, car washes, dental offices were probably the greatest source of mercury in wastewater came from dental technicians, from the procedures that they use. You don't see that much anymore because the use of mercury in fillings is gone, and it's all done with amalgam now. So that's kind of worked its way out of the system over time. But the point being, there's all these things that end up in wastewater that then end up in the biosolids. And so for the past 3+ decades, the EPA and all states, until recently one state stopped, have been taking that material and recommending to use it in agricultural lands as a fertilizer or as a soil amendment, which at the time, I guess 30+ years ago, seemed like a good way to disperse it into the environment, and better than stuffing it in a landfill or incinerating it, which quite a lot of that still happens today. But regardless, the more I learned about it, and the more I learned about this technology that you could use to process this material and decontaminate it and dry it and make it into a usable form. And by that, I mean pelletize it so that it could go through any kind of a fertilizer spreader, seemed like a pretty good idea, and one that would have a lot of value in the waste management industry and in the business of managing municipal waste management activities. So I set about interviewing different manufacturers. I learned a lot from the first one, and then we ended up moving on from them, and actually partnered with a company out of Pittsburgh that's been in business 150 years in the U.S. making thermal treatment technologies, including sludge dryers and pyrolysis kilns. And we continued to work with them for a couple of years to develop our technology, and we added the critical steps of air treatment, because when you heat material like that, you're inevitably going to release a gas, and that's the whole point of it, is to heat the material in a chamber that's agitated. So it's rotating. This material is traveling through it like this, but there's no oxygen in there, so there's no flame inside. It's not incineration because there's no combustion happening. But the heating process releases volatile organic compounds from the solids, and it releases them into a gas, and in some cases, typically it's like a gas with aerosolized oil droplets in it. Well, that gas has a tremendous amount of energy, and it also has the trace amounts of toxins that we want to get out of the material so that we can make safe use of the material as fertilizer. And particularly kind of the poster child for nasty volatile organic compounds these days are PFAS compounds, perfluoroalkyl, prefluoroalkyl compounds. There are thousands of them that are used in manufacturing. They end up in our wastewater. They're in our clothes. Anything you wear that's like quote unquote breathable or water resistant, waterproof probably has some kind of PFAS compounds. Originally, it was used in nonstick applications like Teflon pans. And so if you trace it all back to the kind of the key manufacturers that were developing these materials were like DuPont and 3M. And it ended up in everything, and it's still used in so many things today. But over time, World Health Organizations, including here in the US, have started to recognize that these compounds can have and are purported to have an impact on human health. And in some cases, could be precursors to cancer and a whole host of other potential health issues if the exposure is high enough. And so they're becoming more and more regulated. So I guess back to your question, what got me interested in about what really sparked my passion was first I found that there's a kind of an old, fairly basic thermal treatment technology that has been used in other industries and for other applications for quite some time that could be applied to a one part of our sort of our waste management problems in the developed world. And then I learned that if used properly and coupled with the right air treatment systems and with a good design, could also not only remove contaminants from the waste material, but could also destroy the contaminants. So I was very interested in that. It seemed like a 1-2 punch to really make an improvement in waste management here in the U.S. and here in New York. And so I decided I kind of was already in it at that point, but we decided to try to put a project together here in New York, and we found what seemed like a viable site, and we proceeded.
So because of your passion for that, is this why you started the Northeastern Biochar Solutions?
Yeah. So in 2019, that was right after I left the technology industry. I started looking into this. As I said, I was evaluating, possibly doing something in real estate, but I was much more interested in putting my education and my background to work and to try to do something that would really, I could build a passion for. And that's what I found. So I say incorporated, but I actually set up Northeastern Biochar as an LLC, a Delaware-based LLC in 2019 and at the end of the year in December. And we also at the same time created our first subsidiary, which was to be a project company called Saratoga Biochar, which is an LLC that's based in New York State.
So is Northeastern Biochar Solutions, is that based just on the East Coast so far? Like that's your primary target?
Yeah, we're I mean, the home office is wherever I am. I reside and work in the Saratoga Springs, New York area, so that's where we are, and that's our mailing address is in Saratoga.
And how has this sort of influenced your approach to solving environmental challenges within, like you were saying, like taking the waste, from the car wash and the dentist, and how do you feel, I guess, your company is working to improve the waste that's going on in the world?
That's a tough question. How does it influence me? I guess I would say I just wanted to find a better solution. So if you look around us today, first of all, if you're going to get into anything in the waste management or any industry at all, you can't try to boil the ocean. You can't solve everything, but you can try to make a measurable impact in one area. And so in looking at this technology, pyrolysis technology, coupled with advanced thermal oxidation for air treatment, and looking at the outcome of pyrolysis, which is basically a carbonized end product. So whatever material you put through a pyrolysis kiln, it's going to cook it. Right? In some cases, pyrolysis is used to treat contaminated soils. So if you've got like soils that were like badly contaminated with PCBs or with hydrocarbons, maybe there was spilled fuel at a fuel refinery over time, you can use that technology to pull those volatile organic compounds or to decontaminate that soil. But what you're left with at the end of that is still dirt because there's really very little organic matter. But if you take organic matter and run it through the pyrolysis solution, you basically carbonize that organic matter. And what you end up with is a lot of carbon. And depending on what else is in there, you might end up with a lot of nutrients. So in the case of biosolids, which think about where it comes from, I mean, human waste or animal waste is loaded with macro and micronutrients. It's in a nasty format, but if you can clean that up and get the stuff out of it that you don't want, what's left is carbon, macro, and micronutrients. And that's very valuable as a fertilizer and a soil amendment. There are a lot of areas in the US where agriculture over the past 80 years has depended on synthetically produced fertilizers to grow crops. And it happens everywhere around the world. We manufacture a tremendous amount of synthetic fertilizer products, which, by the way, that entire industry was spawned out of the chemical warfare industry of World War II, really started in Germany. But, the technology was pivoted to make something useful when we made fertilizers. On the one hand, that's been great. It's supported population growth. I mean, we feed our masses with commercial agriculture that uses large quantities of commercial fertilizers that are synthetically produced. But if you really look at how that's done, it's a very energy intensive business. Manufacturing synthetic fertilizers uses a lot of fuel, uses a lot of energy, produces a lot of pollution. And also most of those, really all those products are bonded in some form of salt. And so we're putting what's most needed in the soil when we use those. And if you look at the typical fertilizer, there's this thing called NPK, nitrogen, potassium, phosphorus, nitrogen, phosphorus, potassium's the K. And that's the three primary ingredients for typical fertilizers used in agriculture. And so we put enough of those in our fields to grow the crops. We get the result we want, but over time, that salt degrades the soil. It is actually corrosive in soil. Eventually, over time, with enough of it being used, you have less microbial activity, less fungi. Eventually, you have none. It takes healthy, rich organic matter filled soils and turns it into dirt over time. And I'm referring to, if you think about like really good potting soil, that's almost completely black in color, and it's you can just tell it's loaded with nutrients. It smells rich, and you compare that to take like a bowl of sand. And eventually, if you keep flushing salt bonded fertilizers through that, you get what you need for crop growth, but you ruin everything else over time, over decades and decades. And it's been 80 years now in the developed world using these types of fertilizers. So we wanted to do something that not only solves the waste management problem, even though it's one small slice of the whole waste management pie, it's something that could be addressed. And the outcome of it is useful to restore soil. Because now if we take this material that's been decontaminated and carbonized, it's full of macro and micronutrients. When I say macro, that's the NPK, right? Nitrogen, phosphorus, potassium. Those are the big three. But when we take biosolids or even animal waste and carbonize that, you also get a tremendous amount of micronutrients in it as well. And you don't get that from the synthetic fertilizers. And that's a big difference. And so now we can take this material, recarbonize the soil, reverse the process of degrading organic matter, improve soil health, and actually restore soils that have been completely ruined. I mean, healthy soils have been turned into sand or dirt. You can restore those to a healthy soil again using our product. And you can start growing crops successfully in bad soils almost immediately with our product. So that was like really, to me, that's really what I developed passion around was, okay, here's a solution that solves the problem on the input side and provides a benefit on the output side in the form of soil restoration and an alternative to synthetic fertilizers.
So to dive on that, because you were recently in an article I read and you attempted to permit a pyrolysis facility in New York to convert biosolids and wood waste into biochar, but it was denied by state regulators. Can you comment sort of on what happened and I guess why they're so opposed to it?
Yeah, that's a sore spot. And so that was our first project. And I probably could look back and say, what would I do differently? And what did I learn from that? And I could share a lot with you. But basically, the project that we first attempted in Saratoga County, New York, in the town of Moreau, the opportunity for industrial locations that have the utilities that we would need to run a factory that uses our technology are hard to find in New York. There are a few, and there's usually something missing, right? Like, so they're way too expensive on a per acre basis, or they don't have the utilities. In order for our facility to operate, we need to have a water supply. We need to have, and it best that it's a public water supply. Doesn't have to be, but that's best. And we have to have access to a public sewer because we do have a little bit of discharge. But interestingly, the water we discharge is going back to a wastewater treatment plant, which effectively is where it came from. Same plant, but you know what I mean. And we have to have energy sources. We need some electricity and we need some natural gas. So there's an industrial park in Moreau that has all those things and was very reasonably priced. And they had plenty of land available. And if you look at it on a map, and if you drive to it and stand in the middle of it where we were going to build and look around, there's nothing there. It's I wouldn't call it remote because communities have developed around it over time. But in the park itself, where we would operate, you can't see a house, you can't hear a house, and vice versa. So we thought it was a good place. We were invited to look at that through the Saratoga County Economic Development Corporation, and they introduced us to the leadership of the town of Moreau. We met with the town supervisor in the year, I think first in the year 2000. He was interested. He said, hey, one of our biggest missions is to drive economic development for the town and specifically to drive development within our industrial park, which was completely underutilized. There was only one business that had ever located in that park. The park was like 274 acres, and the only company that ever built a facility in there in almost 30 years was a formaldehyde manufacturer, which would have been right across the street from where we were going to build. And so we had what seemed like a warm welcome, but he said, hey, you have to, meet with the zoning administrator or the zoning person and make sure that what you want to do is that you wouldn't require a zoning change because that's hard to do, especially in New York. And then if that's a go, then you would go meet with the planning board. So we did that. We got a thumbs up on the zoning. We went and filed an application with the town planning board, which really did, I thought, a very thorough job. They spent 13 months reviewing our site plan application. They held, I think it was a total of 7 public meetings, 2 of which were public hearings. And then over time, and they ended up approving the site plan for the project. They also took lead agency in the state of New York. Some organization has to take lead agency for the state environmental quality review. And it's usually the town planning board of wherever, or the city planning board, where a project is proposed to be. The state regulators can do it as well. They typically don't like to. So the town planning board took the lead agency on the state environmental quality review, and they spent 13 months and they approved our project in August of 2022. But in the spring of that year, local residents, specifically it started with people who live right around the industrial park, started to show an interest in it. They didn't really show up for the first public hearing, but they showed up in force at the second one, and they started to oppose the project because they didn't want to have trucks coming in and out of the community, especially trucks that are hauling biosolids in. And they didn't want to have another industrial facility in that park close to their houses that had the potential to generate odors. I could spend an hour with you on how our facility wouldn't generate odors. It's a negative air pressure building and all the air is treated. So that's really, it was a non-issue in our perspective, but they thought it could be a problem. And then they were very concerned about air emissions. At the same time, we had filed our applications with the state of New York for the environmental operating permits we would need from the state regulator. That would have been an air facility permit, an air emissions permit, and a permit to handle a regulated waste. We had to have what New York would refer to as a solid waste management facility permit. So those 2 permits were key. And the other thing we needed from the regulator was what's called in New York a beneficial use determination, which is if you're going to recycle something, a regulated waste like biosolids, and then put it to use somewhere, you have to have what's called a beneficial use determination to be able to do that. That's not a permit, it's a bit different, but the 3 things kind of go hand in hand, and it was all part of one application. The New York State regulators spent 2.5 years reviewing our application. They issued 5 notices of incomplete application during that time, requiring more information from us, answering more questions. We acquiesced and did all that. We were happy to do so. I was surprised it took them so long. We were thinking that the environmental review process would probably be 6 to 12 months, and it ended up being 2.5 years before. And at the end of 2.5 years, they said, okay. And so in January of 2024, they issued us a set of draft permits and what's called a notice of complete application. And so in essence, they're basically saying, okay, our technical review is done. Here's the draft permits. Here's what they look like. Now we have to go out and hold a public comment process and a public hearing. But a really important thing that occurred during the application process, the state of New York labeled certain communities within the state as disadvantaged. And that came out of, so the New York State Air Quality Law is called the Community Leadership in Climate Protection Act. And in setting that up, the prior governor of the state of New York put together a scoping committee, and the scoping committee was tasked with developing certain guidelines and effectively what would become regulations to implement the act, which was the sort of the updated version of New York's older air quality law. So that scoping committee went around the state and determined that there are certain areas of the state that were disadvantaged from the standpoint of in the past they'd had pollution problems and perhaps an undue burden of society's pollution on a subsect of society within New York. So they literally on a map, they've drawn certain boundaries around certain towns. Moreau and its industrial park were not in a disadvantaged community, and disadvantaged communities didn't even exist when we started the application process, but they were implemented. And it turns out that the industrial park in Moreau is within 1 to 2 miles of 2 disadvantaged communities. And that gave sort of the opposition of the project a leg up, so to speak, or a platform to stand on and say, hey, you can't do this here. It's a disadvantaged community. My answer to that was, well, it wasn't a year ago, but it is now. So anyway, they were very successful at putting together a substantial opposition. And what really killed us there was they got several local politicians from very small, like the sort of village mayor kind of thing, up to a state senator and a New York State Assembly person to write letters opposing the project to the DEC or opposing the issuance of our permits. And they also, in the 2023 election, they flipped the was it 2022? They flipped the town supervisor. They voted him out because they thought he was supporting this and they didn't want him. They got enough people to vote against him, and they made enough sort of a rallying cry around it. So that's it. It really ended up being, so we went from, we thought we had the permits in hand and we thought the state regulator was happy. And then after the public comment, public hearing period, the state reversed its course and denied the permits in their entirety. And quite frankly, the denial was kind of mean. They made it sound like we didn't do anything right, which if you look at the record of communication back and forth between us and the agency, you wouldn't see it that way. But so it seemed like an executive level decision. And my first reaction to that was say, okay, well, we respect the agency's decision. We don't agree with it, but we respect it. And then they had a 30-day clock on there that is, if you want to appeal this decision, you have to put a notice in within 30 days. At first, I didn't think we would do it. I mentioned to 1 or 2 news or media contacts that we weren't going to do it. But then our attorneys and our consultants advised me that, okay, well, if you don't at least file intent to appeal, you'll never be able to. So we filed an intent to appeal, and we're just now kind of thinking through whether that's the best path forward. I think at this point, it's probably best for us to try to work proactively with the state to find something maybe smaller. And we've got 2 other project opportunities in the state of New York that are very active right now, where we would be co-located at a wastewater utility. It's smaller, so it's more like on a research and development scale in comparison to the larger facility we had designed for Moreau. But back to your original question, like, wow, yeah, that was tough. I mean, we spent a lot of time and money. We and we put all our eggs in that basket because we had such a warm welcome and it was such a good fit. And we just put all our energy into the Moreau project and we got crushed, quite frankly. And we lost like $1.6 million in the effort. And I don't think there's no way we can recoup that. It was very damaging to a small startup company that's trying to do something like what we're trying to do. Now, meanwhile, as we started to realize that it was kind of sliding southward, we started looking for other opportunities in New York and in other states. And we found other opportunities, in fact, in other countries as well. I've also gotten to know several other sort of waste to value companies that are doing not the same, but similar, applying new technology to solve waste management problems and drive a better outcome. Attempted to do similar things in New York, and I guess they had the brains to get out. Unfortunately for New York, they left. They're very successful now. They have facilities in development and operating in other states and in other countries, but not New York. So I think New York is going to, it's going to come around eventually, but it's going to take some more work. But the lessons learned for me were, okay, don't assume that you have all this alignment early on in a project like that. Probably don't go for a large merchant commercial facility. Like what I'm doing now is trying to partner with wastewater utilities and apply our technology directly on site in a smaller format. And I think that that'll be an easier path forward and probably an easier way for the state to sort of test us and give us a chance, start really more on a research and development scale, something smaller, so that we can prove and we can sort of cure or remedy what they in their denial refer to as inadequacies in our application. And so that gives us the opportunity to do that. But that was tough. I mean, yeah, it was a tough couple of years, and I'm glad to kind of be putting it behind me now, moving forward and finding better places to apply our technology.
With all of that, like, what do you think, I guess, keeps you going and is sort of rewarding in this sort of journey of converting biosolids into biochar? Because I think a lot of people, I wouldn't know any of this personally, and I think a lot of people don't know, because I think most of us don't actually know what goes, like where our waste goes, and that you can turn it into something beneficial. So I think, like, is that you were saying, going on a smaller scale to prove that it does work, and then maybe places like Moreau will say, okay, fine, we'll let you do this, as it's impacting us all for sure.
I suspect we'll never be welcome back in Moreau in any capacity, but that's okay. We're moving on. But interesting that you said most people don't even really think about what happens when you flush the toilet. Where does your garbage go? People just want to see it disappear, and what they don't want. And one of the toughest things is to recognize that what I'm doing effectively, in order to take a waste, no matter what it is, do something, at scale to really make a difference, you have to bring it somewhere to do something with it. And you have to develop a facility. And so what are you really doing is you're developing a waste management facility. If you think about that, especially in the Northeast or maybe in California, where nobody wants a waste management facility in their town, even if it's not nearby. I mean, they will just jump on that bandwagon right away to oppose it, even if they don't even have any idea what it is or how it works. And that's human nature. I get it. I understand it. It's unfortunate, but it is what it is. I guess what I've gotten out of this, at least, is, for one thing, we've had quite a bit more time to test and develop our technology. We had a very successful extended pyrolysis test in the Midwest this past summer. We processed 150 tons of dried biosolids. We created about 70 tons of premium biochar carbon fertilizer. We had the opportunity to lab test the inbound feedstock and the outbound product extensively. So I have a whole new ream of data from third-party independent labs that I can use in our next application cycle, which I didn't have that when we were in the application cycle for the Moreau project, but we have it now. So the point being, Megan, we've learned a lot more. I've learned a lot more about, how to go about citing projects and what to watch out for. And here's one of the things that I'll point out about Moreau in our first attempt. I grew up in New York, in central New York, not in eastern New York, not in Saratoga County. I didn't know that there was this horrible history where General Electric had contaminated large areas of the greater Glens Falls, New York area with PCBs. And a lot of people there had, for a generation have had, elevated cancer levels and real health problems. And I didn't even know that going into it. I gotta be a little bit more research oriented about, where we think we're going to go on topics like that. And that's one of the really important things that I learned. So I get it. These people they don't want to see something in their community that could end up being a source of health impacting pollution again. And I don't blame them. That's not what we would do ever. It's not. I mean, we're here to solve a problem, not to create one. But I get it. They're paranoid, because they've had a rough go the last 50 years. And quite frankly, the worst of that contamination from GE occurred before New York State even had a regulatory agency for environmental. It started in the 40s. So, I understand all that. But the other side of what I've really gotten out of it is I've met a lot of great people. I made a whole host of new contacts and professional network around the world. And so one of the interesting things is, despite all the negative publicity, and there have been probably close to 300 news stories about our Saratoga Biochar project, most of them in the Eastern New York sort of local, but the word spread nationally and internationally. So through that, as unfortunate as the outcome was here in New York, it's been one of the best free marketing tools I could have ever had, because people who work in the waste management industry or in the industry of producing solutions for waste management large municipalities, people who are responsible for managing waste. There's a lot of people out there that are very interested in what we're doing. They've reached out proactively. And so the network has grown tremendously. And at this point, the number of opportunities that we have, I couldn't possibly address them all in the rest of my lifetime. I mean, I'm 57 years old. I don't plan on doing this till I'm 100. But the appetite is out there for the people who are in the know, and for the people who are interested in finding new technologies to better address the problems that we have with waste management in society. The interest is there, and that's been maybe the most rewarding thing for me so far, is to and that's focusing on the positives, right? That there's just been a tremendous amount of interaction that I've had, and new people that I've met that are very supportive and understand what we do. It didn't fix my issues with Moreau, but it opened my eyes. And as I said too, it gave us a lot of time to continue to develop our technology and do more testing and build our relationship with our manufacturers more deeply, and to also develop relationships with potentially new manufacturers, so we have more options on the table for fabricating the technology that we would use.
We were talking about the devastation in Los Angeles, and kind of thinking of all of their, I guess now, not biosolids, but their waste from all the houses and destruction, and because of, you can kind of make biochar with so many different things. I'm wondering if that's an option for them. I mean, I guess down the road, just because all the cleanup, like I was just thinking, like, a fire in New York or somewhere, like, would you ever consider using, like, do you ever use things, I guess, like a house burnt down or a forest to try and make, like you said, like, put it in the soil and the plants and help that regenerate? What about people's homes and things like that? I was just out of curiosity.
Well, the technology that we have could be applied to that sort of thing. So, I mean, effectively, that's kind of like construction waste. It's not new construction. It's tear down. It's half burnt, but you got all kinds of stuff in there. God knows what's in there. But yeah, I mean, this type of technology could be applied to that sort of a cleanup. But the concept of carbonizing organics, that's not going to apply very well to a structure that was made of concrete and steel and glass. So there's some limits there, I think. But yeah, there's potential. I think the thing that you'll see happening over the next decade is you'll see pyrolysis and gasification, which is not the same but similar technology, used to treat not only biosolids but a wide range of waste materials, especially food waste. You can have almost the same outcome with a very macro and micronutrient rich carbonized end product if you use this technology to address food waste. With food waste, you have you have to do some pretreatment. It typically it's mixed with food packaging and you got tinfoil, metal, glass, whatever. You got to do some sorting, but there's a great potential to use food waste and have a better outcome as opposed to putting it in a landfill. But I think especially with regards to biosolids, or really any of these things, most of it now is going into a landfill or it's being land applied. And so these contaminants that are in these materials today are just being pushed back out into the environment. I mean, modern landfills have water retainment systems, but inevitably there's always the liner of a landfill is eventually it's going to give out 40 years down the road, maybe 20, whatever. Eventually there's going to be a failure point, and leachate, or the liquid that forms, that gravity pulls down on the ground, eventually it's going to get out. And it's got some nasty stuff in it that just ends up in the groundwater supply. And especially if you're talking about, if we're considering like PFAS chemicals, which are often referred to as forever chemicals because they don't just naturally break down in the environment. They're around forever practically, unless you get them hot enough. I mean, there are ways to break these things down, but it's not going to occur in the natural environment. If these compounds work their way down into the earth and they're buried under, a couple million years of whatever and end up getting compressed, they're going to come out in lava somewhere sometime down the road. They'll be changed by that point in time, but it's not going to matter to us by then. But if you want to really address these issues, we have to do something different. Right now, we're just pushing all this waste back out into the environment. If it's going into a landfill, you can call it whatever you want. It's going back into the environment. Anything and also interestingly, landfills, as you probably are aware, they tend to generate a lot of methane, which comes up out of the landfill, and that's like a 25x greenhouse gas coefficient. It's a very potent greenhouse gas. And recent studies by the EPA actually indicate that the methane actually pulls PFAS compounds up out of the landfills and into the air. So, I mean, it's like if we don't deploy these kind of technologies, we're not solving these problems, and we're having in the aggregate large amounts, although they're spread out quite wide, large quantities of potentially health impacting compounds in our environment, and they always end up back in they end up in our drinking water, they end up in our food. So it's a nasty cycle. We got to do something to break that cycle.
Which is why we've started this whole thing, to gain insight for myself and so many people that have no idea what biochar is or what exactly happens to our waste, our garbage, etc. I mean, I think about that all the time. Thank you this was so informative, and I really appreciate you taking the time out to let the listeners know everything. And we'll put all your information for your company too, because like you said, that so many things like this are all connection, and you never know. And now so many companies, like the people that are doing biochar in places like Namibia and things, and I think they think, oh, it's just wasted, we can't do anything with it, but really we can make it go back into the earth in a positive way. And I think that's what's important to this whole podcast and trying to get people onto the environmental sustainability, because we're not here for a long time, but we got to make it worthwhile. And like you said, things that are not good are leaking back into the environment. And I think things, companies like you're doing, because a lot of people don't want to deal with waste. And I think having a company like yours to show people that there is a positive attribute to what comes out of us that goes back in.
Yeah, we can do better, Megan. We can put a rover on Mars and gather samples that someday we're going to get back and do all these kind of things. We can manage waste far better than we do today, and I'm committed to help make that happen. In my little piece of the puzzle, I'm going to solve that.
I think that's the biggest thing. I think that's exactly what we want. We need people like that, and getting the word out. It's amazing that the word can go out for so many other things, and I think it's important. Yeah, this, and just the devastation in California and global warming and, all these different things going on in the world. And I think people are just taking not a backseat, but they're not quite paying attention to everything that's going on in the world. And so I think this is really important. So I really appreciate you being on the show and talking to listeners and just giving us your story and telling us where we can go with this.
Of course. Anytime. Thanks for your time, Megan. I appreciate the opportunity to speak with you today, and I look forward to seeing the output of this podcast. I'll be watching.